Friends, welcome back to my channel. In this session we will see, while working on welding machine, inverter welding machine, why the thermistor gets blast, why the thermistor damages. Basically it is a part of inrush current protection circuit. It is a question from one of my viewer. He asked me, sir, in welding machine, why this PTC or NTC damage? Basically it is a type of resistance which is used to protect the inrush current. When we see the diagram here, when we see the practical circuit here we have bridge rectifier, that is here. Here is input line terminal. After bridge rectifier there is a component that is used in series with positive line. I simplified this diagram to understand it easily, and then we will see what is the reason for its damage. Bridge rectifier, positive line is forced to pass through this PTC. Either it is PTC, either it is NTC. One is the negative temperature coefficient, the second is positive temperature coefficient. Both have to limit the current, and both components, these are basically thermistor family. Its resistance will change with change in temperature. Why it is used? Basically it is used to protect these capacitors, because these are bulk capacitors. These are very large size in capacitance which are connected here. Might be you can see it. These are looking in between these heat sinks. These capacitors are here. Never touch any capacitor until you are confident that it is discharged. If you don't have a good practical experience in power electronics, never try to repair, never try to touch it. First of all, before touching this circuit, because it have a very huge bulk capacitor size, it is 0 volt. It must be verified before touching it. Okay, let's move to the circuit. These capacitors produce a huge current sink when the power is applied. So it can cause to damage the bridge rectifier, it can cause to trip the circuit breaker, anything. Or it may be, if we have a huge size fuse, it will damage. To protect from any damage and to protect these capacitors, because when the capacitor is empty, its internal resistance is equal to 0. That is not 0, but suppose it is equal to 0. To protect it from huge short circuit current, inrush current, that is most of the time approximately 10 times to 20 times than the system current. So it will damage the machine. To protect it from any damage, to protect from overcurrent losses, PTC or NTC is used in the positive series line. So current have to pass to charge these capacitors. Because our machine is working at 220 volt, that means this machine will work at 330 volt DC. To power on our power stage, it uses a low voltage power supply. So this power supply will turn on at 100 volt DC. So we can say when the capacitor will start charging. Okay, let's see the capacitor charging time constant. Voltage to time and voltage. The capacitor charge in this way. At this stage, at its first charging constant, 63%, at that time its internal resistance is near to 0. So at that time If you connect directly to a bridge rectifier, to any charging source, it will draw maximum current that can damage the circuit, that can damage the all items in the board. Why? Because at that time this current, this surge current, this inrush current is approximately 10 to 20 times more than the system current. For that purpose, to limit the current, a series resistance is used to charge a capacitor. When this capacitor will reach in this safe limit, at that time its routine current, its charging current will become to a normal stage. Why? Because this time the voltage level is increasing. For that purpose, a bypass relay here that will bypass this NTC, a bypass relay is used. Normally the current will pass through this resistor. When this relay is turned on, here if we have 110 ohm for example, and here we have 0 ohm resistance, so current will select the easiest path. Now we can say at this point we have 110 volt, 100 volt DC, because our bridge rectifier is providing DC voltage. It is taking AC voltage here, direct AC line voltage, and it will provide DC voltage. This is our positive terminal, and positive terminal is connected to this component that is here. Either it is NTC or PTC. The PTC is positive temperature coefficient. Its resistance will increase with increase in temperature. NTC is negative temperature coefficient. When the temperature will increase, its resistance will decrease. In normal power supplies, low power supplies, the NTC is used, and in welding machine the PTC is used. Why? When there is some high current, at that time its internal resistance will increase. So no problem, either it is NTC or PTC. Some machines have NTC, some machines are using PTC. Okay, when the voltage will reach at this point, we can say 110 volt at this stage, because now the capacitors are reaching in safe limit. At that time a low voltage power supply that is connected at the same capacitor line, positive voltage, PTC. After PTC, the circuit is connected to this positive terminal from the inside connection of these PCB tracks. So this point is connected here. Same time we are taking positive and negative voltage to this low voltage power supply that is here, that are reaching here. So this power supply will turn on. When it will turn on, it will turn on this relay. Low voltage power supply is connected at the same points. It will turn on this relay. When this relay will turn on, it will close its contacts. Initially the current was passing through this resistor, so it will protect these capacitors from overcurrent, from inrush current, from surge current. When the surge period will pass, at that time this relay will turn on. Why? Because this capacitor bank is charged at some safe limit, safe voltage. If due to any reason, if we have some short circuit here, we will see now, if any component is short circuit, this capacitor, either it is internally short circuit or external short circuit due to any other components connected on the DC rail, at that time it will not allow to build the voltage, because this power supply needs, we can say 110 volt to turn on this section, this one. If it is not turning on, that time our DC rail is being discharged to the next short circuit, so it will cause to draw maximum current all the time through this NTC, PTC thermistor. So it have its own specifications, its limits. When a continuous strike for the overcurrent condition is provided to this component, at that time its disk temperature will increase from its limits. So it will damage, it will blast. So its basic duty is to protect the circuit from overcurrent. It is not used for any continuous operation, because it is just only, we can say it is for milliseconds, because these are huge capacitors. For that purpose, maybe it will take 100 milliseconds, 200 milliseconds, we can say, to charge at specific voltage level. We have two components in series, one resistor, one capacitor. At initial stage, it have, we can say, its internal resistance is 100 milliohm, and this is 100 ohm, 110 ohm. At that time it will drop all the voltage here at that time, because capacitor have zero voltage. When capacitor will start charging, at that time the capacitor internal resistance will start increasing and its resistance will start decreasing, because when capacitor is being charged, its internal resistance will start increase. At that time its dropped voltage will start to decrease, so its load will decrease. At that time this bypass relay will bypass this component, so it will be bypassed. So it is a protection circuit, inrush current protection circuit. Let's see practically. We have AC voltage. Initially current have to pass through PTC, these points, after that DC line. We are taking voltage from this point. These are reaching here from this wire, that is here, at approximately 100 volt, 110 volt. When this capacitor will reach 100, 110 volt, our this supply will turn on. It will provide 5 volt and 12 volt to control card, pulse transformer driver circuit. It will also provide 24 volt to this relay winding, that is here. This is bypass relay. Our PTC NTC thermistor is here and bypass relay is here. Initially the current will pass through this component. When the low voltage power supply is turned on and we have voltage here 24 volt, at that time this relay will turn on and it will close its two contacts internal, so it will make a jumper from here to here. The current, first it was passing through this component, now the current will pass through this arm and it will reach to the capacitor. What are the possible reasons for this PTC blast? There are three possible reasons. The first, we have high power switches that are IGBTs here. Most of the time it is in push-pull stage, H-bridge configuration, any configuration. We can see one IGBT is at positive side, the second IGBT is negative side. Same here, positive, negative. So these will switch in cross. This pair or this pair. If this pair will on, at that time the current will pass through the transformer winding and it will complete its circuit. If this IGBT will turn on the positive side, this will on, the current will flow from this circuit. This or this, this or this. Now, if there is no drive signal, ideally it is open circuit. If it is open circuit, the capacitor will remain charged. At that time there will no current flow. But unluckily, any two, this or this, are all four, 2 or 4 IGBTs are damaged. What will happen at that time? Because when IGBT is damaged, it works as a short circuit. So it will allow a direct current flow because it is now uncontrolled. When uncontrolled, it will give a short circuit. At that time, the capacitor the capacitors are not being charged, and this capacitor and this NTC is total 100 ohm resistor. If it is 100 ohm resistor and we are applying 220 volt here, at that time it will cause to draw more and more current. What will happen? At a specific level, its internal plates will damage, because it have its own limits. When it will not allow to draw full current, but the system is drawing more and more current, and system is not shifting in the bypass. Why? Because this power supply section is not being turned on. When it is not turning on, that means the capacitors are still below the limit. The problem here in DC rail, this is the biggest fault in these machines. If IGBT set, MOSFET set is short circuit, it will blast this PTC most of the time. The second problem, if this power supply, its MOSFET is damaged, it will also cause a short circuit on DC rail. The third problem, this relay, because this is a power relay, most of the time its points making breaking, and these make sparking. When it's sparking, its contact arms will damage. At that time, if this relay is turning on but its points are not closing the circuit, at that time the current have to pass through this PTC. How we can isolate the problem? Disconnect IGBTs. This is the first issue. You can check with multimeter. Set multimeter to continuity. Connect between positive and DC rail, positive and negative DC rail. So it is short circuit. This time, this machine, the 4 IGBTs are damaged. Remove it from the circuit and then check it here. It must open. Okay, the first thing. The second problem, if there is still continuity, there is still short circuit, then come to this power supply module. Here it is using an external module which is installed here. If it is using external power supply, that's okay, that's good. You can remove this jumper. So this is the 300 volt DC rail. It is taking voltage from here to power on this power supply. If there is still short circuit, if the short circuit is finished, then we can test this relay. Remove machine from the power line. Remove this connector. How we can test the relay? Just only remove this connector and apply 24 volt here at the winding of this relay. These 2 points. When you will apply power here, these 2 points must be closed. It will give continuity. In normal condition, it will give 100 ohm resistance, that is from this PTC. When it is powered on, it must give 0 ohm resistance. So these are the 3 possible causes for damaging this PTC. And if you see this circuit diagram, it is 230 ampere machine. Here it have some EMI filter, and after that here it have MOV. Then the current will pass through this PTC, that is here. Then it will reach to the bridge rectifier. Either it is using before bridge rectifier or after bridge rectifier, that is the same. Most of the Chinese machines, they are using after bridge rectifier, as we discussed here. In some machines, this PTC and this current limit protection circuit is before bridge rectifier. If it is before bridge rectifier, it will also protect the bridge rectifier. Voltage will pass from this resistor and it will charge this capacitor bank. When it is charged at specific level, at that time this HT voltage are here. positive HT. These are provided to transformer, and this SMPS circuit, 3842 circuit, it will turn on and it will provide 24 volt output here, that are here. These 24 volt will provide to these three relays, 1, 2, 3, and these relays contacts are here, 1, 2, 3. So it will bypass this PTC NTC thermistor, and that time the system will start charging at full rated current. So it is the circuit which I simplified here. To troubleshoot it, remove IGBTs, test them separately. Then if still there is short circuit, remove these 2 points, which will isolate the power supply. If the problem in power supply, you can repair it. And then third stage, you can test this relay and this fault will finish. I hope so this video is informative. If it is informative, hit the like button. If you have any question, let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.